Hello and welcome back to my Project Euler series in Python. This is problem 9, special Pythagorean triplet. A Pythagorean triplet is a set of three natural numbers a, b and c, where a is less than b and b is less than c, for which a squared plus b squared is equal to c squared. For example, 3 squared plus 4 squared equals 9 plus 16, which is equal to 25, which is equal to 5 squared. Okay, there exists exactly one Pythagorean triplet for which a plus b plus c is equal to 1000. Find the product ABC. Okay, so let's break this down. So we need to figure out a way to generate some Pythagorean triplets or generate some a squareds and b squareds to see if they generate a square number, and then take that a, b and c, check its sums to 1000, and then print the product. So let's start with generating some c squared values for a in range 1000. Let's just do it for now. I can fine tune the limit in a bit. 1000, and well, already do a bit of fine tuning here. We can start with a plus 1 because we know b is not going to need to be less than or equal to a. So then we can say that c is equal to the square root of a squared plus b squared, and we can just call the math square root function. And then if c equates to the int value of c, i.e. it was wholly divisible or wholly square rootable, then the decimal form should equal the same value as the integer form. And if it did have stuff left over, then obviously it's not going to be the same. But if it is, then we can print a, b, c. Okay, let's give that a try. Okay, so this is a little bit annoying with the float, but it makes sense. And obviously, when a is 0, everything's a Pythagorean triple. So let's put that to 1, and let's set c equal to int c, because, well, it should be. So okay, that tidies things up. So now I've got a bunch of Pythagorean triplets. So let's see if we can fine tune the limits quickly. So for a less than b less than c, and we know they need to sum to 1000. So if a is any bigger than 333, then b and c will be also guaranteeing that the sum will be greater than 1000. So a as a maximum has to be less than or equal to 332. So let's go with 333 here, and then under the assumption that a is super low, let's call it 1. If b is like 500, then obviously c would have to be 501, which would be greater than 1000. So I guess the case for b is like, let's just call it 500 just to be a round number. Okay. So, excuse me. So this should mean that we're only going as high as we need to for a and b respectively. So that means the limits should be okay now. So we've generated Pythagorean triplets within the desired range, so we now need to check which one perfectly matches the desired sum, and then just print the product. That's super easy. So if a plus b plus c equals the product, then we can print, equals the 1000, which is our desired sum, then we can print the product. Okay, format the file, Okay, sweet. So we get 31,875,000. And apologies, yes, I've done a lot of these problems before. So unfortunately we don't get to type it in, but we can see the answer and we got it right. So I'm pretty happy with how it looks. I guess once we found it, we don't need to continue through the rest of all the options. So we could create like a found flag, for example, and while it hasn't been found, keep going, but as soon as it has been found, we can set found to true, and then we can break immediately out of that inner loop, that B loop, and then if it has been found, then we can break out of the A loop as well. And that should stop the program a bit faster. Okay, let's just double check that still runs fine. Okay, sweet. So yeah, runs relatively quickly. I'm happy with this structure, so let me know if you have a different way of doing it, anything faster, cleaner looking. And yeah, let me know in the comments, and I will see you next time.